Okay, for what we have in the case of problem number 6, okay, we're looking at graphing all the asymptotes of the following function. So here we have f of x is equal to x squared minus x plus 5 all over x plus 1. And in the case of what we have for the domain, okay, so we have that x plus 1 cannot be 0 in value. And from this, we have that x cannot be at -1. And since x plus 1, from which we have the 0 issued for that -1, is not a factor of the numerator, x squared minus x plus 5, we have this exclusion from the domain to be the vertical asymptote. So we have the vertical asymptote at x equal to -1. So we have on the side of what we have, at least for the vertical asymptote. Okay, so here we have placing, okay, so we have x equal to -1. And in terms of any other asymptotes, and now we have, and just bringing this to fuller view, okay, we have, in comparing what we have between the degrees of the numerator and denominator. So we have a highest degree term in the numerator is x to the second, so we have n equal to 2, and in the denominator, okay, we have from x, which is the higher degree term in the denominator, we have that m is equal to 1. And for what we have in comparing the degrees, okay, so we're going to have that n is greater than m by 1 degree. And from this, now we're going to have a slant or oblique asymptote. And for what we have in the case of the slant asymptote, now this will be arrived at if you have a linear denominator. You can use either synthetic division or line division. Okay, so we have for the slant asymptote, now we have y equals, and for what we have in the case of taking what we have with x plus 1, the divisor, into the dividend, which we have at x squared minus x plus 5. All right, so we have x into x squared is going to be an x, and distributing x over x plus 1, so we have x squared plus x, and taking the difference, again, with line division, you're looking at row by row subtracting, so x squared will go out, and we have what's going to be negative x minus x, so we have negative 2x, and we can bring down the plus 5, and x into negative 2x, okay, we have it minus 2, and distributing negative 2 over x plus 1, so we have negative 2x minus 2, and we have taking the difference. Okay, so we have 5 minus negative 2, so that is going to be at 7. And for what we have in terms of the quotient, okay, this would be the slant asymptote. Okay, so we're going to have that y is equal to x minus 2. Okay, so we're going to have, again, a slant line. And for what we have in the case of transferring, okay, what we have here, so we have with, again, the slant asymptote, that y is equal to x minus 2. Okay, so we can plot some points here. Say we have on x minus 2, say if x is 0, y is going to be at negative 2. So we have with order pairs, so we have, in this case, so we have 0, negative 2. I can plot a point. And also if I have on the x-axis, if x is 2 and y is 2 minus 2, well, y is going to be at 0. We can plot the point. And in joining together, okay, what we have here, so placing the first point, so I have at 0, negative 2, and also at 0, 2. And checking what we have with this function, the result is correct. Okay, for what we have in the seventh problem, it says to graph the rational function f of x is equal to 2x minus 3 all over negative x plus 3, and it says to graph the function, draw the horizontal and vertical asymptotes, if any, and plot at least 2 points on each piece of the graph, and then click on the graph icon. Okay, so we have with this particular item. Okay, so we have in this problem. Okay, now starting out looking at what we have with the asymptotes. Okay, so on the side of the vertical asymptote. So again, vertical asymptotes will originate from exclusions in the domain whose fact terms will remain after the function is put in simplest terms. So here we have negative x plus 3 cannot be 0, and if I take away 3, we have negative x cannot be negative 3, and so for we have excluded from the domain the value of 3, and so we're going to have a vertical asymptote at x is equal to 3. Now, in looking at what we have in comparing the degrees, so the degree of the numerator is going to be at 1, and from negative x, the degree of the denominator is equal to 1, and so we have, in comparing the degrees, we have that n is equal to m, and from this, now there will be a non-zero horizontal asymptote, and we're going to have that y is equal to the ratio of the coefficients of the highest degree terms from the numerator and denominator. And we have 2x over negative x, and this reduces to negative 2. So we have a vertical asymptote at x is equal to 3, and a horizontal asymptote at y is equal to negative 2. Okay, so in looking at plotting, okay, so we have x equal to 3, and we also have y is equal to negative 2. Okay, so we have the asymptotes. Now, in looking at plotting a couple of points on either side, okay, so what we can do here is that, okay, so you have x equal to 3, y equal to negative 2, okay, and in taking now again, so you have for x, you have y equal to 2x minus 3 over negative x plus 3. Okay, and we'll pick a couple of points of x less than 3 and a couple greater than 3. So let's say we have 1, 2, 4, and 5. Okay, so we have in this particular case, right, so we have for x equal to 1, so you got 2 times 1 is 2, minus 3, so we have negative 1, and you got minus 1 plus 3, so in this case we have y at negative 1/2. And taking what we have now with x at 2, 2 times 2 is 4, minus 3 is 1. The negative of 2 plus 3 comes out to positive 1, so we have that y is equal to 1, so we have 2, 1. And for what we have for x at 4 and x at 5, so we have with x at 4, we have 2 times 4 is 8, minus 3 is 5. And we have the negative of 4, which is minus 4 plus 3 is negative 1. So you have y at negative 5. And whenever x is 5, 2 times 5 is 10, minus 3 is going to be at 7. And we have the negative of 5 plus 3 is negative 2. So we have negative 7/2. Okay, so we have additional points. So we have at 4, negative 5, and 5, negative 7/2. And so just transferring what we have now. So you have for plotting points. So you have 1, -1/2, and also we have 2, 1, also we have 4, -5, and we have 5, -7/2, and plotting. Okay. Okay, so after plotting the points, I'm going to go ahead and X out. Okay, and we have just linking together. Okay, so you have this little graphing. Okay, so testing out, and the result is correct.